This video goes over maximum and minimum word problems. In order to be able to determine the maximum or minimum value for a quadratic, you need to be able to get the given function into vertex form. So let's practice that here. So first thing you're going to do is factor out whatever number is in front of the x squared out of the first two terms. The next thing that you're going to do is take the middle term, divide it by half, and square it. And you're going to add and subtract that value. Next step is to factor those first three terms as a perfect square. And then you're going to apply whatever you factored out at the beginning to your correction term. And then finally, you'll collect the like terms at the end. Let's try again with example B. So first thing I'm going to do is factor out the number in front of the x squared. Then I'm going to take the middle number, divide it by 2, and square it. So 2.5 squared. Then I'm going to add and subtract that value. Next step is to factor those first three terms as a perfect square, and I'm going to move my minus 6.25 out of the brackets by multiplying by 2. And then finally, I'm going to collect my like terms at the end, which gives me my final k value for the vertex. So let's apply that in some problem solving. So our first question here is to find the minimum product of two numbers whose difference is 10. So let's let x represent the first number. And then what we want is a product between x and between a number that is 10 larger than x, or x plus 10. Now we actually have a quadratic equation that we can expand. And now we're going to complete the square to find the vertex, because the minimum of this parabola is going to give us our answer to the minimum product. So let's go ahead and complete the square. No number to factor out in front of the x squared, so we can go ahead and divide 10 by 2 and square it, and then add and subtract that value. Now we can factor those terms as a perfect square. Which gives us our vertex of minus 5 minus 25, which tells us that our product, minimum product, is minus 25 and is achieved with the numbers minus 5 and a number that's 5 larger than that, positive 5. Let's take a look at another example involving area. So here we're asked to determine the maximum area of a triangle. We know the area is 1/2 base times height if the sum of its base and its height is 12. So let's let x represent the base. Let's put x in here into our diagram. And now we know we need an expression for our height. So we know our base plus height is equal to 12. So that must mean that our height is 12 minus b, or in terms of our variables here, we can write that as 12 minus x. So now we can calculate the area in terms of x as 1/2 x times 12 minus x. And now, just like the example above, we can expand to get a quadratic that is in standard form. So I'm going to have 6x minus 1/2 x squared. And now I'm going to complete the square. So I'm going to factor out negative 1/2 from my x squared term and also from my 6x term dividing by half really means that you're multiplying by 2. And now I'm going to divide by 2 and square it. And then I'm going to factor my first 3 as a perfect square. So x minus 6 all squared. And then I'm going to take out my minus 36 and multiply by minus a half, which gives me plus 18. So then I know my vertex is 6, 18, which tells me that the maximum area of a triangle is 18 centimeters squared when the base is 6 centimeters in this scenario. Let's do a third example that goes with ticket prices and sales. So here we have the student council plans to run the semi-formal dance. Last year, the tickets sold for $15 each and 500 people attended. The student council decided to raise the ticket prices, and they figured that for every $1 increase, the dance attendance would decrease by 10 people. And I'm looking for the ticket price that is going to maximize the revenue. So the first thing I know is that my revenue is going to be my number of tickets sold times my price per ticket. And I need to define a variable that I can put in those brackets that's going to work with my question. So last year, they sold 500 tickets and the ticket price was $15. Now I want to increase my ticket price by a number of $1 increases. So let's let X represent the number of $1 increases. So that means that for every $1 increase, my number of tickets sold is going to decrease by 10. So this is my equation here. The next thing that I'm going to do is I'm going to expand and put my equation into standard form. So let's see, I've got 500x minus 150x, and then minus 10x squared. So let's just turn that around. So my x squared is at the front, plus 350x plus 7,500. So even though the numbers are a little bit larger, my approach is still the same. I'm going to factor out 10 from my first two terms so that I can complete the square. So I'm going to divide 35 in half and square it, which is going to give me 306.25, and I'm going to add and subtract that number. And then I'm going to factor the first three terms as a perfect square. And then I'm going to take out my 306 number at the end by multiplying by 10. So 3,062.50 plus 7,500. And then I'm going to collect those last two terms, which is going to give me 7,806.25, which is actually my maximum profit. But that's not what the question is asking. I'm asking for the ticket price. So I know that my ticket price is going to be my original $15 plus 17.5 increases, because that is the x coordinate of my vertex. And I know that each increase represents $1. So my total ticket price is going to be 15 plus 17.5, which is going to give me a ticket price of $32.50. So therefore, the ticket price that would maximize the revenue is $32.50. The final example is a little bit different. We're talking about the motion, and so sometimes we're interested in some different characteristics. So here we have the height of the football kicked from the ground is given by this function here. We're looking for when will the football reach its maximum height. So this is the x-coordinate of the vertex. And then the second part is what is the maximum height of the football. This is the y-coordinate of the vertex. So just like our previous examples, we're going to take our function and we're going to complete the square. So starting the same way by factoring out -5 from both terms. And then we're going to take the middle term or the t term and we're going to divide it by 2 and square it. And then we're going to add and subtract that value. This allows me to factor the first 3 terms as a perfect square. So t minus 2 all squared. And then I can bring out my correction factor at the end by multiplying by -5 that I had originally factored out. So plus 20. So now my vertex is 220, which actually answers both questions for me. So the football reaches its maximum height at 2 seconds, the x-coordinate of the vertex, and then the maximum height of the football occurs at the vertex, and it is 20 meters, So another way to interpret the question, 4 different scenarios that are applicable to real-world problems. Using the quadratic function allows us to model those situations and then answer questions about them.